I welcome all of you to the class. In the previous class, we had started the concept of the interpolation, and today we'll be talking about what do we understand by the interpolation. Okay, before I go into the procedure of doing the interpolation, how we do the interpolation, okay, I will first of all take an example, okay, and uh, the example I'll be taking from a type of interpolation called the Lagrangian interpolation. Lagrangian interpolation. Okay, so we talk about the, I will be first of all talking about the Lagrangian interpolation. And uh, before I talk about the theory of this Lagrangian interpolation, what it does and what is it used for, let me take up an example. Okay, for example, we are given some values of x. Okay, and we are also given some values of y, and y is a function of x. Okay, so if we have for x is equal to 0, the value of y is 0. For x is equal to 1, the value of y is 2. For x is equal to 2, the value of y is equal to 8. For x is equal to 3, let's suppose it's given to us the value of y is 27. Let's take up only 4 points. Fine. So we are given at x is equal to 0, y is 1. At x is equal to 1, y is 2. X is equal to 2, y is 8. And x is equal to 3, y is 27. For different values of x, we have different values of y. Okay. Now, first of all, look at the intervals. The gap, what we call as the interval, is 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. We say this is an equally spaced interval. This is an equally spaced interval. Okay. This is an equally spaced interval. Okay. Now the question for us is, find the value of y when x is equal to 2.5. At x is equal to 2.5, at x is equal to 2.5, what is the value of y? This is a question for us. Okay, that is given is when x is equal to 0, let me suppose here y is also 0. When x is equal to 1, y is equal to 2, x is equal to y is equal to 8, x is equal to 3, y is equal to 27. Now the question is, if the value of x is 2.5, that is 2.5 will be here. Okay, if the value of x is 2.5, what is the value of y? I have to find the value of y. This is what we use interpolation for. And the procedure of doing the Lagrangian interpolation is, because before I go into the theoretical details of this interpolation, let me first of all see how this method works. Okay, as far as the formula for this interpolation is, or the basic crux of interpolation gives us an equation between y and x. It gives us an equation, or I should say it gives us the relationship. Interpolation is gives us the relation between, it gives us the relation between y and x. For different values of x, you have different values of y. It will give us a formula between y and x. Okay, and in that formula we will be substituting the value of x to obtain the value of y. Fine. Now look how many points we are given. We are given essentially 4 points. We have 1 point is here. This is one value of x. This is x2. This is x3. This is x4. Given are 4 values of x. The formula for Lagrangian interpolation is y of x. I will be deriving in a while from now this Lagrangian. Let me first of all discuss how it works. Y of x is equal to y1 multiplied by x minus x2 multiplied by x minus x3 multiplied by x minus x4. We are having 4 terms. This is our x1, this is x2, this is x3, and this is x4. Okay, so the first value of y is equal to y1. This is y1, this is y2, this is y3, and this is y4. So y of x is equal to y1. X is any value of x minus x2 minus x3 and so on, divided by x1 minus x2 multiplied by x1 minus x3 multiplied by x1 minus x4 plus y2. See, when we were taking the term y1, it was for x is equal x1. In the numerator, we will not be having any x1 term. And the denominator, all the terms will be subtraction from x1. It is x1 minus x2, x1 minus x3, x1 minus x4. In the same way, when we are asked about y2, it will be multiplied by y2 multiplied by x minus x1, but there will not be any x2 term in the numerator. That will be x minus x3 and x minus x4. Okay. And in the denominator, we have to take all the subtractions from x2. So first will be x2 minus x1. Okay. x2 minus x1 multiplied by x2 minus x3 multiplied by x2 minus x4. Okay. Now let's go to the third term, plus y3 multiplied by no x3 term in the numerator. So we'll be having x minus x1 multiplied by x minus x2 multiplied by no x minus x3, okay, but x minus x4, divided by all the subtractions will be taken from x3. So it will be x3 minus x1 multiplied by x3 minus x2 multiplied by x3 minus x4, okay, plus the last term, that is y4 multiplied by x minus x1 multiplied by x minus x2 x minus x3 whole divided by x4 minus x1 x4 minus x2 multiplied by x4 minus x3. Fine. These are the, so we are having only four values, y1, y2, y3, y4. This is the Lagrangian formula. Okay, we'll be deriving it in a while from now. Now substitute the values. How we will be substituting the values? Substitute the given values in this equation. So we will write this equation. I will be writing here. Y of x is equal. Now I have to find the value of y at x is equal 2.5. So at this place at x you will place x is equal 2.5. So we will write none. Therefore we can write this as y at x is equal 2.5 can therefore be written as this is equal y1. What is the value of our y1? Y1 is 0. Therefore this entire term will become equal 0. No need to write this entire term. Okay. So I will write this is 0. So this term goes, plus y2. How much is y2? Our y2 is 2. So I will write this as 2 multiplied by. Then you have x minus x2. You are finding the at the value of x is equal 2.5. So it is 2.5 minus x1, that is 0, multiplied by x is equal 2.5 minus x3. x3 is equal to 2 multiplied